Hello, everybody. Thank you for staying so late at the day for the last session. My name is Barak. I'm going to talk to you about two main issues, what's happening at the edge and about SmartNICs. So I want to start with a short video. Let's see if it works. I want to start with a short video getting us a little bit into the mood, also getting a little active later today about augmented reality. So in 5G, we have a lot of demand for new features, and augmented reality is one of them. And it needs a lot of low latency. So
walking down the high street and you see a museum. It can identify objects in the museum. What the main difference is, where AR is very flat, AN actually observes the scene and identifies the elements within. It then attaches the information very intelligently and accordingly. There are massive opportunities for the hotel industry. You can not only browse for room availability, but also take a look inside the room before making a booking.
Okay, so what do we learn from this? The main takeaway from this short video is that if you want to have low latency, you got to have more logic and application closer to the edge, closer to the users. So let's define what I'm calling here the virtualized edge. So what I'm calling the virtualized edge, and there you can see a different list of terms. Everybody calls this slightly differently. What I'm trying to refer to is the last point in the network where you can put applications and servers. So this is what I'm referring to as the virtualized edge. One can argue that you can also put servers at the customer premises equipment at the customer site. That's also true, but this is not what I'm referring to here in what I call the virtualized edge. So actually, the virtualized edge is the last point where you can put applications and you can put logic and CDN and whatever you want at closer to the user applications. And as you've probably seen throughout this event, this is actually happening right now. Also, you can look at the survey that's mentioned here. So this is not something that's going to take place like 3, 4, 5 years. This is happening right now. So what's actually happening at the edge? On the one side, you have the cloud providers. Cloud providers want to provide more and more functionality and feature closer to the edge. So I listed here 3 applications, the Amazon CloudFront, Lambda Edge, and Azure IoT Edge. Those are just 3 applications from the cloud providers that are being placed right at the edge. I looked at the Amazon CloudFront list, and there's actually an edge from Amazon right here in Amsterdam. So this is just an example. You don't have to go all the way far to a large data center. You're addressed by a closer one. Lambda Edge is an interesting service. I'm not sure if all of you are familiar with Lambda Edge. Lambda provide from AWS provide a different paradigm. Right until now, we're all talking about virtual machines and VNFs and later on containers. Lambda provides a different paradigm of what's called serverless. Serverless means you only need to build your application, put it somewhere in the cloud, and then whatever cloud provider, they will manage this for you. So this is a different paradigm. So it simplifies things, and also the business case is different. You only pay for the time the application runs. If it doesn't run, then you don't need to pay for it. So Lambda Edge is, in addition to the service provided by AWS, they also provide you a locality, meaning you put some logic at the edge, and you're able to steer, to do redirection of the HTTP request according to the user device, and the location. On the other hand, we have the carriers. The carriers are coming from a different perspective. You have central office, POP, hub nodes, whatever you call them. What do you have there today? So today, if you open up the door for a cord for a central office location, you usually have a bunch of boxes, and they're dedicated boxes and do a specific service. And the idea is, the same, and the idea is to replace them and put servers and run virtualization on top of those servers instead of the dedicated servers. So this is actually happening today, right now. Carriers, NFV is actually happening right now at the edge. They're not replacing the big boxes at the data center, but they are replacing the equipment at the central office. Let's review a list of activities and projects that are right now relevant to the edge. I think the pioneers in the areas of open source projects towards the edge were Cord. Chord or central office re-architected this data center was also mentioned in the previous session. It's an open source project that aims to provide a full solution to some applications. For example, one application is residential, another is mobile. So they take the architecture of the data center. So you have the leaf and spine switches, and you have servers, and they're all connected and managed by some networking entity, in this case, ANOS, an SDN controller. And what's nice about Chord is that they provide a full application. So you plug it in, and you get a full application of, say, residential or mobile. Open edge computing is a totally different approach. The idea in this open source project is to allow all the users and all the applications to access the shared resources. So they place some shared resources at the edge, and the idea is to define APIs, and each application, regardless of the carrier and the vendor, will be able to access those resources at the edge. OpenNFV has done several projects related to the edge. They started off with Edge NFV. Edge NFV is just a report. It's a document that specifies what's the requirements that were found to be relevant to the edge. Then they moved to Virtual Central Office. Virtual Central Office is very similar to Chord, but it's managed by a different SDN controller. They use Open Daylight instead of ANOS, but it's a very similar approach. Edge Cloud aims to provide an edge platform, so this is a different one. Multi-access edge computing is totally different. This is a standard body. There was a workshop on Monday specifying all the activities listed in MEC, and they define what application needs to do, what are the APIs, what is the management to provide solutions at the edge. Starling X and Ecrano are the new initiatives. Those are two open source projects, are quite new. I think both of them are not yet fully active. Starling X is built on the contribution from Wind River of Titanium. This is an offshoot of OpenStack, and it provides virtualization at the edge specific, meaning they're more containerized. Starling Ecrano is based on contribution by AT&T. Last one is Edge Foundry. This is an IoT-related platform for IoT applications to collaborate on the edge. Let's examine what we have at the edge. So at the edge, what we typically have is a very limited place. So we have a very limited space, very limited power consumption, so it's a small solution. Maybe you can fit 3, 4, whatever, 10 maybe servers, but each place has a different characteristic, and it's all small. On the other hand, there's exponential growth in the number of applications you want to put at the edge, and number of subscribers you want to put at the edge. Some of them are, just IoT devices, but the number of the growth is exponential. So there's a trade-off. You want to put more and more stuff, but you have limited power and space. Additional challenges is, of course, security. As soon as you put applications at the edge, very near the users, you have to secure them. So you have to secure both the location, the applications, and also the user segregation, so they will not be compromised. So this is, of course, always the first challenge. Openness and future-proof are also important. What is openness? Openness is just to step away from the vendor lock-in that you have today. So let's assume that you want to place some new applications right now today. You go to the central office, you open up. You have a bunch of dedicated physical functions. Now, if you want to introduce new application, new services on top of them, you have to go to the vendor, ask them, and if they will be willing to open up and put the applications that you want, they will charge you an arm and a leg. So you want to be open. You don't want to be vendor lock-in. Future-proof is the same thing that, if you look at the future 3 years from now, one thing for sure is that we do not know what will be the requirements. We don't know what's going to be there, so it's going to be future-proof. So you have to put something programmable that you can change without sending technicians to the central office. If you have thousands of central offices, changing the equipment there is quite expensive. Multiple applications per site means that you have different applications, both from the cloud providers and the telcos that are competing to get in there, so you have to be able to support all of them. And of course, low latency we also already discussed. Now let's go to the other side. So we're talking about network packet processing offload. So what are the methods to offload packets processing from the offloading from the CPUs? So the term, what is the difference between SmartNIC and a legacy NIC? So a network interface card is the legacy thing. You plug it in to a server and it provides connectivity. Now, SmartNIC allows two things. First thing is offloading network functionalities from the CPUs to the NIC, and the second is programmability. So what are the options for SmartNICs? First option is using the traditional ASICs. The problem is the traditional ASICs are very low on programmability. Maybe you have a small CPU core, but this will consume quite shortly, and programmability will be consumed. Another option is not to do acceleration at all. You can use the CPUs, and the different networking between the virtual machines can be offloaded to the other cores. But then there is a penalty. You want the cores to be used for VNFs, and if you consume them just for the connectivity between the VNF, you miss the purpose. NPUs are a different option for doing SmartNICs. NPUs, network processing units, are specific ASICs that have built-in CPUs that process packets. The little caveat with this is if you write specific software that fits into the NPU, it's not easily portable to another NPU. So if you take a different card with a different NPU, you won't be able to easily transport the code that you wrote. So you have some kind of vendor lock-in. Last but not least, FPGAs, field programmable gate arrays, are hardware devices, but you can change them on the fly, meaning you can change your hardware device. They're very good at packet processing. They're very good with deterministic performance. But the benefit of that is that you can change them on the fly, so future programmability. Microsoft Azure appear here because they were the pioneers in the area of SmartNICs. Microsoft Azure is a large cloud provider, and they were, I think, the ones that named the term SmartNICs. They were the first to use this term. So they've been using SmartNICs for a long time now. And in NSDI, just in this year, they opened up and told us a lot about their experience using SmartNICs. So it's very interesting to learn from, the ones that are leading the edge and the leaders in this market. So what did they do? The first thing they said, by the way, there's a link here. I recommend you read this. It's very interesting. They did a report trying to analyze the different options for SmartNIC. So they started off with the hardware devices, the ASICs. They're not programmable, so they ruled them out. The worst approach from their perspective is using the CPUs. They said this kills the business, right? The business of Azure is to sell virtual machines to customers. And if you take those precious cores and move them just for network, then you lose the business. NPUs, they found out they are not scalable, meaning they can maybe do the job today, but they're not scalable to support you in the future. So they ruled them out. And they stick to the FPGA that they had. So they have 4 generations of SmartNIC based on FPGAs. And the reality is that it met their requirements. The fact is that they're using successfully offloading all the networking from the CPUs onto the SmartNICs. And they're showing that less than 1% utilization for the networking. Let us now example the requirements of the Smart Edge and how the Virtualized Edge and how SmartNICs address them. We discussed scalability. So scalability is, of course, easy for SmartNICs. They are ASIC devices. If you offload the networking, they can easily support a high bandwidth. And if you put TTRs alongside the SmartNICs in the SmartNICs, then you can also scale with the number of subscribers. So low power and minimal space is interesting. So let's say that you need to support 100,000 subscribers in one location, but the space is just small, and you need 10 servers to meet the requirements for this, but you're only able to fit 3, so you're deadlocked, right? You cannot virtualize this central office. So here comes the SmartNIC. You offload all the networking into the SmartNICs, and all of a sudden you only need 2 or 3 servers. So not just save space from 10 servers to 3 and save power, but this also makes this feasible. Security is a different direction. In a recent research by Moore Insights and Strategy, they claim that SmartNICs can help isolation, flow isolation for security of the virtualized edge. So, of course, SmartNICs cannot solve the entire security, but they help serve as an anchor point and differentiate between the different flows. So this is a big asset for the security. Open is avoiding vendor lock-in is quite interesting. I'm not sure if you're familiar, but if you write code for FPGAs, you use high-level languages such as Verilog and VHDL, and they're easy, you can easily port this and use either Altera devices or Xilinx devices. So there is no actually vendor lock-in. So even you can move between generations of FPGAs, just simply compile and put the new code, the same code into a new FPGA. So this totally avoids the vendor lock-in. Regarding future-proof and compact, of course, that the FPGAs are reprogrammable, so you can try and envision that you'll put the different software alongside when the new requirements come in. And you can usually support a lot of applications using the same FPGA with just different images. And of course, we mentioned the high performance. FPGAs are not only high performance, they're also deterministic, so you'll get the same results time and again. Moving to the ASNICs, there is just a recently announced press release of the ASNIC 100 from Ethernity Networks. This is a new NIC that provides 2 ports of 25 gig, 2 ports of 40 gig, or 100 gig. It includes 10 DDR, so you can do packet buffering. The nice and interesting thing is that it provides a full solution. So before we talked about offloading the NFVI, the virtual switch functionality. By using PCI pass-through and SRUV, you can actually offload the entire functionality of things like virtual EPC, virtual BNG. We actually have a demo that we're demonstrating using SRUV, moving the entire data path of virtual BRS into the SmartNIC. So you get a full solution, including not just the card itself, but the image into the FPGA and the software APIs around it to get a complete solution from Ethernity Networks. We also use DPDK API, so there are open APIs, and you can easily replace and use whatever functionality that you want. You're not vendor locked into a specific implementation. In case you're not familiar with Ethernity Networks, so Ethernity Networks has been around for 14 years now. Since June last year, we're a public company, traded in London Stock Exchange. We're experts in the area of telecom and FPGAs. And there are more than 500,000 device systems out there using our FPGAs. So what are the key takeaways? First, cloud and virtualization are happening at the edge right now. There are certain challenges you need to meet when you want to deploy virtualization at the edge. SmartNICs help you address all the requirements of the virtualized edge. And Ethernity Networks provide a complete solution for the virtualized edge. Thank you.